In this video, we're looking at conversions between bases, but we'll specifically be going in one direction. We'll have a number in base 10, and we want to convert that to another base. And I notice I have an error here because I did some copy and paste, and I'm going to change that. It has to do here with process, and it says to convert from another system to base 10. I want this to be to convert to another system. We want that to be from base 10. And you know what? I'm kind of glad I made the mistake because I want you to notice it's totally the opposite. So going to another system from base 10, instead of doing multiply and add, we do exactly the opposite of that because this is reverse. We divide and subtract. I made the video going in the opposite direction earlier, which is why I had the copy and paste error. But this is actually a good comparison. You're going in the reverse order. So instead of multiply and add, you're going to divide and subtract because you're doing exactly the opposite. Here, as well as in our previous process, going in the opposite direction, you want to write out the place value that you're concerned about. And in this case, I noticed that we're going to be working with base 5. That's what I want to change this into. So I'm going to write out my place value. And I'm not entirely sure how many places this is going to take. I could think about it a little bit, but I'm just going to write some places. And actually, I've gone way too far, but that's okay. Right? Place value keeps going, there's no end to it. But now as I think about changing 87, our number 87 from our base 10 that we work with every day, I need to think about what's the highest number on this place value chart that can go into an 87. That's why we're talking about divide. It's how many times it can go into, how many groups that large fit inside of an 87. Well, 625 is way too big and 125 is too big. But I can divide 25 into 87. And so that's going to be my first step. I'm going to ask how many groups of 25 are there in an 87? And I started with base 5 again because I can think in terms of money. If I'm a cashier and I need to give you 87 cents in change, I'm going to start out with 3/4 because that's the biggest coin I can fit into 87 cents. So that's going to go in 3 times because 4/4 would be 100, which is $1. 3/4 is 75. And when we do the subtraction, we find that we have 12 left. So we have so far 3 groups. I'm going to squeeze it in here because I'm not leaving myself much room. 3 groups of 25, but I still owe you money. If I owe you 87 cents and I give you 3/4, that's not enough. So how am I going to make up that extra 12 cents that I owe you? Well, I go down to the next coin. I'm not going to give you 12 pennies. I want to go to nickels next. So we say how many nickels go into 12 cents? Well, 2 of them, which gives us 10 cents, leaving a remainder of 2. So I've given you 3/4, 2 nickels, and we do need to even think about the pennies. I don't know if you care very much about pennies, but we should. So the number of times that a penny goes into 2 cents is twice. We need 2 pennies. And so if I give you 3/4, 2 nickels, and 2 pennies, that is 87 cents. So 87 in base 5 is 322. Or, because we can use coins here, I'm going to keep doing it, 3/4, 2 nickels, and 2 pennies. Okay, so that's an idea to keep in mind. Again, you may want to try this next one on your own. Perhaps pause the video right now and then come back. Once again, I see that we're working in base 5. I've got a 1's place, a 5's place, a 25's place, a 125's place. But actually, I notice I don't need to even go that far. Again, because this is 115, it's not 125. I can't fit a 125 into a 115. So I can put some groups of 25 into 115. I know that 4 times 25 is 100. So that gives me 4 groups of 25. I have 15 left over, and I move down to the next place value. How many of those will fit? Well, those are nickels, or 5, and I can fit 3 of them into the number 15. Now, here's a mistake people sometimes make. They say, oh, there's no remainder left. I'm down to 0, so the answer is 4, 3. That is wrong, because if you write 4, 3, you're saying you have 4 5s and 3 1s, not 4 25s and 3 5s. You actually have to consider the 1's place, and I even go ahead and do the division process, even though it seems really obvious. This is why you've seen me on earlier videos never leave that out and always work with a 0. We want to account for every single place value. And for that 4 to be over there under the 25, we need to have the 0 in the 1's place as a placeholder. Okay, so 115 or 115 in base 10 is 430 in base 5. So once again, if you want to pause and try it on your own, go for it. Check back in when you're done. Here I've gone farther over with my place value because I see that I have a number that's actually in the thousands place. I'm working with the number 1,382, but I see that once again I've gone too far. I don't need to go all the way up into the 3,125's place because 3,000 is too big to fit into the number that I'm trying to convert. So into the 1,382 right here, 1,382, I can't fit a 3,125, but I could fit a 625. So we're going to divide 625 into 1,382. And you know what? Not only does it go in once, but it's going to go in twice, right? 2 times 600 is about 1,200. So 625 is going to go into 1,382. So that'll go in twice. This is 1,250. You are welcome to use a calculator. Have it out and available, no problem. Okay, so I have 132 left over, but I know I have 2 groups of 625. Maybe I'll just keep track right in here. Usually I do it underneath my place value. So 132, that's my remainder. Now I move down to the next place. How many times does 125 fit into that? Well, hopefully we can see that that's going to fit in there one time. One group of 125. So we are going to divide and subtract. When we subtract here, we get a 7. So this went in one time, right? It went in one time. This place value went in 2 times. We've got a remainder of 7, and we need to move down to our next place, which is the 5's place. How many 5s will fit into the 7 that you have left over? Well, 1 of them. So we have one group. Oh my goodness, I skipped over something. That's okay. I'm just going to let the video run. Can you see where I made a mistake? I keep talking about how important it is to check all the bases and not to skip them and not to leave them out. And I think because I was seeing a 7 down here, my mind immediately jumped to the 5 because the number 7 is close to the number 5. We can't skip over any bases, otherwise we won't have those placeholders, those zeros, where they need to be. So I actually need to think, how many groups of 25 go into 7, which is my remainder? And 0, none, right? 25 doesn't fit into 7. 0 times 25 is 0. We still have 7 left over. But we need to account for that 0. I need to have that placeholder in the 25's place. Otherwise, my 1 and my 2 in the other places aren't going to be where they need to be. The 0 is very important. So now, how many 5s in a 7? Well, just 1. It's still just 1. So that goes in 1 time. I have a remainder of 2, and we need to go to our 1's place and say how many groups of 1 fit into 2. Well, 2 groups. Okay. So reading off my answer there, I have the 2 from right here, and then I have a 1, a 0, a 1, and a 2. Well, that was pretty symmetrical. So the number 1,382 in base 10 is equal to 21012 in base 5. Notice I'm not saying 21,012. 1,000 has a specific number. It means 10 times 10 times 10. So whenever I'm in a different base, I just read the digits 21012 base 5. Okay, so we've done 3 examples in base 5 in order to get ourselves up and running and understanding the process. But now we're going to do base 3, base 2, base 16. So we're going to switch it up. The idea is the same all the way through, and that's the important part, is the concept here. It's not just being able to work in one base, but being able to work with any base. So here we have base 3. And I want to put 38 into base 3. I'm going to think a little more carefully about my place value. Always a 1's place, then it's going to be the base, then I keep multiplying by the base. Once I hit 27, I realize that that number is pretty close to my 38. If I multiply by 3 again to get another place value, I'm going to be up at 81, which is bigger than the number I'm trying to convert. So I don't need to go that far. So I'm not just going to write place values like crazy. I'm going to think about it a little bit. So I want to take a 38, our familiar number 38 in base 10, and figure out how that would be written in base 3. So we say, well, how many groups of 27 fit into 38? And that's going to go in 1 time. And it's going to leave a remainder of 11. So this is 1. Maybe I want to start writing in my answer already. 11 is the remainder. I go down to the next place value, which is a 9. 9 fits in once, and we get a remainder of 2. Excuse me. So 1 group of 9. I have a remainder of 2. I want to try to fit some 3s in there because that's my next place value. How many 3s fit into a 2? Well, it won't go in at all because 3 is bigger than 2. But we go ahead and write it up even though it's a 0. Sometimes people feel like, it's just a 0. It's nothing. Ignore it. No, super important. Otherwise, the other numbers aren't where they need to be. And I did a subtraction error. Right? Because 2 minus 0 is in fact 2. Then we move on to the next place value. How many ones fit into a 2? Well, 2 of them. Just a little something about base 3. It's kind of a nice base to convert with because your only digits are 0, 1, and 2. So the highest that one of your place values is going to fit into one of your numbers is 2 times. So you're only ever multiplying by 0 or 1 or 2. Those are the only digits that can come up because base 3 only has those three digits, 0, 1, and 2. So we're going to move on to a problem in base 2. And here, the only digits we can possibly get are 0s and 1s, right? Because it's base 2, 2 digits, 0 and 1. Place value. 1's place, it's base 2, 2, and 4, and 8, and 16, and 32. If I double again, I get a 64. And that is bigger than the number that I'm working with. So I'm not going to go that far because the number I'm working with is only a 42. So we divide 32 into 42. It goes in once, leaving us with a remainder of 10. So I have one group of 32. And then I look at my 16's place. Even though I know that I can't fit a 16 into a 10, I'm actually going to do the work and show the work because those zeros are important. They hold the places open that we need. Still have a remainder of 10. Next place value down is 8. It will go in once. Remainder of 2. I'm just kind of writing my answer as I go down the line. So I have a remainder of 2, but my next place value down is 4, which I know goes into 2 0 times because 4 is bigger than 2. My next place value is 2. 2 divided by 2 is 1. And now I have a 0. Don't neglect the 1's place. If you do, your answer will be wrong. If I don't have the 0 that I need at the end by saying, well, 1 goes into 0 0 times, that is going to push all of your place values down, and your result is not going to be equal to what you're trying to add up to. So 42 in base 10 is 1 0 1 0 1 0. And you can check that, by the way, by reversing the process and do the multiplication and add and see if 1 0 1 0 1 0 in base 2 gives you a 42. You can check it by going in the opposite direction. So now we're going to really challenge ourselves with base 16. So place value, 1's place, 16's place. This number up here, that's pretty big, 685. I think I better multiply by 16 again. It's 256. Now, if I multiply by 16, I'm going to be in the thousands, which is too big. So these are the place values that are going to be helpful to us. And here we go. Again, our process is divide and subtract, divide and subtract. So we say, how many times does 256 go into 685? It's not going to go 3 times. That would give us something too large. So it looks to me like it's going to go twice. 2 times 256 is 512. So we get a remainder of 173. So I have 2 groups, maybe I'll throw it in the box again. 2 groups of 256. And then I need to say, how many times does 16 go into 173? Well, 16 goes into 17 once. I'm going to do some real long division here. Bring down. Oh, that goes in 0 times. Okay. So 16 goes into 173 10 times. Now that's actually kind of problematic because I can't have 2 digits in one place value. And this number up on the top is supposed to tell me how many groups of that next place that I have. It's 10. I can't stick 2 digits in one place. But remember, in base 16, a 10 isn't written as a 1-0. A 10 is written as an A. So I have A groups of 16 in 173 because A is 10 in base 16. So my remainder is 13, and I'm down to the ones place. How many times does 1 go into 13? Well, it goes in 13 times. Uh-oh, I have the same problem. I can't stick number 13 in the ones place. It's got 2 digits. Yeah, but we're in base 16. So after 9, we have 9, then A, B, C, D, E. So which one is a 13? Well, A is 10, B is 11, C is 12, D is 13. So our answer here is 2A, D. No, it's kind of pushing it. That's pretty different for us. We're not used to having numbers that are letters. I'm not talking about algebra. These aren't variables. This is 2AD, which is 2 groups of 256, A groups or 10 groups of 16, and D groups, which is 13 groups of 1. Okay. So again, we've got another example coming up. It's in base 16 again. You can see the place value written on the page. If you want to pause and try it on your own before I do it, this would be a good time. And you can see I'm getting started on working this problem. I've overdone it with place value because we're trying to write the number 100 in base 16, and a group of 256 won't fit in. So I'm not going to need that. I'm not going to use that. I'm going to start with 16 and say, how many times does 16 go into 100? Let's see, 4 times 16 is 64. Another 16 gets us up to 80. Another 16 gets us up to 96. So it goes in 6 times with a remainder of 4. So I have 6 groups of 16 that fit into 100, and there's 4 left over. And 1 goes into 4 times with no remainder. So the answer is that 100 in base 10 is equal to 6, 4 in base 16.